Hello and welcome. It's me, Ashish Agarwal. Today we are going to explore a very interesting and hot topic, figuring out if an essay was written by a student or by a super smart computer. In a world where real and computer-made stuff mix, we'll look at the little details that help us tell them apart. Get ready for a quick and interesting trip into the world of text detection. This project deals with the task of figuring out who wrote an essay. Was it a student pouring their thoughts into the paper, or was it a work of a super smart computer known as large language model? Our goal for today is straightforward. We want to become adept at classifying essays accurately, drawing a line between those crafted by students and those generated by advanced language models. Why is this important, you might wonder? Well, in the evolving landscape where humans and artificial intelligence intersect, understanding who the author is carries significant weight. Talking about dataset, the dataset for this project was sourced from Kaggle. The QR code can be used to view the base dataset. However, the provided dataset is very limited. As you can see in the images here, there are only 3 data points for LLM generate essays. So what do? We feed the same prompt to different LLMs and increase our dataset. I've utilized some freely available data generated from different LLMs. We'll talk more about this later. Listed here are some of the NLP techniques I've used in data preprocessing and feature generation. Tokenization. Think of it as breaking down a sentence into tiny building blocks tokens. Part of speech POS tagging. Like a language detective, this technique assigns a grammatical label to each token, revealing whether a word is noun, verb, adjective, and so on. Lemmatization. It brings them all back to the root form. It simplifies our analysis by focusing on the essence of words. Stop word removal. It filters out common words that don't carry any much meaning, allowing us to focus on the more important bits in the text. Spell checking. This one is interesting. I've used this for generating features. As you may have understood, uh, student essays are bound to have more typos compared to a well-built LLM. Punctuation analysis. It is the same as spell checking, checking for commas, colons, and semicolons. Collocation analysis. Just as some words prefer to stick together, collocation analysis identifies those strong word associations, providing a deeper understanding of language nuances. Text vectorization, TF-IDF. It is one of the most important or rather base techniques in NLP, transferring words into numbers. TF-IDF assigns weight based on their importance in the document. It's our way of giving priority to those words that truly matters. These are some of the better performing models that I've trained my data on. Logistic regression. It is a simple yet effective model. I've used cross validation, that is k-fold validation, to avoid overfitting. The data training, testing, and validation data were split based on stratifying target variable, and I used a constant seed to maintain reproducibility. Ensemble methods. Ensemble methods combine the strengths of multiple models. It's like having a diverse group of experts contributing their insights to arrive at a more robust and accurate classification. Logistic regression along with SVT classifier get pretty good results in my. Finally, neural networks or rather deep neural network hyperputting parameters back and forth and training consumes a lot of time. Use dropout layers, early stopping to reduce complexity and time. Also use validation loss as a metric for monitoring the training. As you can see in the slides, different features were created using NLP and other algorithms. Some of the features to name are paragraph count, word count, sentence count, spelling counts, collocation count, mean sentence count, etc. Also, you can see the spearmint correlation among the features and target variables. Area under ROC curve was one of the evaluation metrics. Accuracy, precision, recall, F1 score, confusion metrics, etc. were also used to evaluate the model performance. There were many challenges faced during this project, and how challenging is the fun part. First of all, the provided dataset was limited. Research other dataset that has been publicly available looked into generating data from different LLMs. The provided dataset is only for 2 prompts, that is only assessed from 2 topics. So it goes without saying there would be some bias in our dataset if we are going to use it for other essays. Preprocessing NLP is tough. The model gets complicated and preprocessing alone takes much of time. The process was done on Kaggle with CPU and 12 GB of RAM. Next step would be experimenting on advanced models and more feature engineering. Okay. Thank you for your valuable attention. Now I'd be happy to address any question you may have. Please feel to contact me about the project methodologies or any other aspects you are curious about.